table. Here we go. Du. The derivative of t squared is 2t dt. Don't forget the dt. And then for the antiderivative of this is what? 1 over the beta. It's all right, sine of beta t. Beta does stand for b. It's just Greek. Everyone agree with this table? Any questions on it? All right, so this is equal to, all right, ready for the formula. Ultraviolet, these two multiplied together. Since 1 over beta is a constant, I'm going to put it in front. 1 over beta, t squared, and then sine beta t. All right, that's ultraviolet. Minus, leave a space, integral voodoo. Voodoo is this, right? Voodoo is this. These two multiplied. All right, when I multiply these two together, what is a constant that I could pull out? 1 over beta is a constant, and 2. I could pull both of those out of the integral. So I'm going to put it out here as 2 over beta. Instead of like 1 over beta times 2, I'm just going to put 2 over beta. And then what's still in this integral? Sine beta t and a t dt, right? Sine beta t and a t dt. I'm going to write it this way. T sine beta t dt. All right. That's where I am. Any questions on how I got that? This new integral that I got, I can't just do it mentally, right? I look at that and I'm like, crap, it's still something I can't do. But I can do integration by parts on this. So this I'm going to treat like a new, brand new problem. So I'm, again, going to go do some scratch work. This right here, I'm not going to bring the 2 beta. I'm just going to bring the integral. I'm going to do it over here. So we've got integral, this is my scratch work, integral t sine beta t dt. I have to do my table again. And it is okay to use u and dv again in your table. That's okay, because as long as you work it with this as like its own self-contained problem and eventually get your answer back to t, then it's okay to come back over here and plug it in, all right? All right, so what are we going to use for u? T, right? Because it's going to get better, right? If we let u be t, in the new integral it'll be 1, and then everything should work out. Sine beta t dt has to go here. And now I differentiate this to get du. So that's just 1 dt, not dx, dt. This is v equals antiderivative of this. Good, negative 1 over beta cosine beta t, right? Because the antiderivative of sine is negative cosine, but then you have to scale by 1 over beta because beta is a constant. This is a linear expression. And so, this now becomes ultraviolet, these two multiplied, right? That's the first thing, ultraviolet. So that'll be negative 1 over beta times t cosine beta t. You can put this in any order you want. You could have put t times that, that's fine, but normally we put constants before variables and then that goes before trig functions. That's just ultraviolet, right? Minus, I'm going to run out of room. Where do I put, I'm going to go over here and do it. No, because we're in the middle of this problem, aren't we? Yeah, I can't erase that. I'm just going to have to make some room here for myself right here. So this is going to be ultraviolet, negative 1 over beta, t cosine beta t. Okay, minus I'm using ultraviolet minus voodoo. So ultraviolet minus integral, space in front, voodoo. Voodoo are these two, aren't they? Multiplied. Any constants I can pull out? Negative 1 over beta can come out. And when it comes out, right here, negative 1 over beta, what happens? It turns into a plus. Plus 1 over beta. And then inside I have cosine beta t, dt. And this integral, we should be able to handle now. The antiderivative cosine beta t is going to be 1 over beta sine beta t. That's again using that whole idea of this is a linear expression in here. So we have to scale by 1 over beta. Okay, 1 over beta. And now this, like I just said, becomes 1 over beta sine beta t plus some constant. There's a little bit to keep track of here, huh? It's a lot to keep track of. So now I'm ready to come back here and fill in this purple thing with that. So I have 1 over beta t squared sine of beta t minus 2 over beta, and then all this times, I need to put all that in parentheses. Why does that need to be in parentheses? Because there's two terms here, right? There's two terms. There's this and this. So I've got to put all this in parentheses and distribute. This negative 2 over beta must distribute through to everything that's there. So negative 1 over beta t cosine beta t plus 1 over, I'm going to do that 1 over beta times 1 over beta, make it 1 over beta squared, sine beta t. And then the plus c, I'm going to decide just put the plus c way out here on the outside. Last step, I'm going to distribute the negative 2 over beta through here and here, and that'll be my final answer. I'll put it here. My final answer is 1 over beta t squared sine beta t, okay, plus 2 over beta squared. That's just me multiplying this times this, and two negatives become plus t cosine beta t, and then distributing again, right, through here to here. We have negative 2 over what? Beta cubed sine beta t plus c. There you go. I'm not going to check my answer. I mean, I don't mind, but I wanted to see if I can't squeeze one more problem in before we go. At least get it started.
Where did the first 1 over beta squared come from?
The first 1 over beta squared. Right here?
No, the next one.
I've already erased it. It came from the second time I did integration by parts. When I did my integral, when I actually had that integral on that second integration by parts, I had to do a 1 over beta to scale out the beta. So we got an additional 1 over beta in there. I can't, yeah, it's already gone. But you can watch the video. Here, I'll wave. This is when you were asking, right? Okay. Yeah. Yeah. What do you think? How does it feel to you? I mean, the looks on some of your faces are like what I normally get, right? I'm used to seeing. in a class like this. And that is that, hey, I mean, this is it. This is Cal 2. This is the real deal. There's a lot to do here. There's a lot to keep track of. And we're only on our second technique. We have 5, right? There's a lot to keep track of in this class, which is, I think, what makes it so hard. Maybe I need to be more positive. I'm not trying to be negative. I'm not trying to be negative. It's not, I know it comes across as I'm trying to be negative. There is a challenge in front of you, okay? There is a gauntlet in front of you, and you're either going to go and try and push through it or you're not, okay? But you're not just going to sit here and not do the work at home and expect to get through the class. That's not going to happen, all right? I don't care how smart you are, you've got to do the work, all right? All right, so here we go. We'll do one more. You know what, I'll save that one for next time. Next time's a test. How about this one? This one is not, I think this is easier than the one before, for sure. That's x to the 4th times natural log x dx. So here's, in the problem we just did, right? It was something like t squared, I don't know, was it sine, cosine, beta t, something like that, dt? When we did that problem, we had to use integration by parts twice, right? And the idea is kind of like, okay, you start with t squared. The first time through with integration by parts, you kind of knock that power down by 1, and you create a t. And then when you do it the second time, you're taking derivative of t, and it becomes a constant, which makes things work out, right? So you might be thinking, okay, well, whenever I see like variable to power, I'm going to let that be my u, and I'm going to just chip away at it, right? Just kind of, if I need to do integration by parts several times, I can do it until that power of t or x comes down, right? Like in a problem like this. Say, okay, well, shit, am I going to have to do integration by parts 4 times here, right? Like start out with x to the 4th. First time through, you're going to get 4x cubed. Second time through, right? X squared, then x, then a constant, right? No, that's not what you're going to do, all right? Not for this problem, because if we do it the other way, right? If we do it this way, let u be the natural log of x, and let dv be the x to the 4th dx, yes, this gets more complicated this way, doesn't it? It becomes 1/5 x to the 5th. But what does this become? The derivative of that is 1 over x dx, right? The antiderivative of this is 1/5 x to the 5th. And do you see that voodoo is actually really nice? Right? Because what happens if I take x to the 5th, ignore that, who cares about that? X to the 5th times 1 over x. It just cancels off 1x and you have x to the 4th. Can you integrate x to the 4th? Yes, right? So this problem is a lot easier than it looks if you do the right table. If you do it the other way, and you let the u be the x to the 4th, and the dv be what? What's the only choice for dv then? ln x dx. Now you have to ask yourself, what's the antiderivative of the natural log of x? We have not talked about that, have we? We know what the derivative of it is, right? Do we know its antiderivative? We don't, do we? Right? So we'd be stuck. All right, let's finish this problem out, because this is not going to take us but a minute or two. So y'all ready for ultraviolet minus voodoo? Ultraviolet are these two multiplied. 1/5 x to the 5th times natural log x. That's these two multiplied. Minus a little bit of a space there, integral voodoo. The integral of voodoo. These two multiplied. Any constants come out? 1/5 comes out. And what happens when you take, like we said, that 1 over x and you multiply it times the x to the 5th? X to the 4th, right? Just cancels out 1 power, dx. And we know the antiderivative of x to the 4th, right? It's just 1/5 x to the 5th. And Chris, this is what happened in that previous problem. We had a 1 over beta on the outside, but then when we did the antiderivative of the cosine thing, I think it was, beta, we had another 1 over beta come and join the one that we had pulled out. That's why we got a 1 over beta squared.
Oh, when you got the
Yeah, when we did the ante, we had to scale a second time, well, scale again, and that created that second one. Like here, we're going to get another 1/5 here, aren't we? We have a 1/5 here already, but when we do the antiderivative of that, we get another 1/5 x to the 5th plus c. And then this is still here. So we only needed integration by parts once. Ultraviolet minus the integral voodoo. Here's the antiderivative. I think I'm ready for a final answer. 1/5 x to the 5th natural log x minus 1/25 x to the 5th plus c. There we go. Last one, and then we'll talk about the exam briefly. All right, so do you remember on this step right here, we said if we had done this, we would have to do the antiderivative of natural log, and we don't know what that is? Okay, well, let's find out what it is. What is the antiderivative? Not derivative. What is the antiderivative? What's going on with my speech today? Antiderivative of the natural log x. Well, do we know any methods to do this? All we have is one, integration by parts, right? The other stuff won't work. So if we're going to do integration by parts, what are your options here? You don't have a lot. What does u have to be? What does dv have to be? U has to be the natural log, right? And then the dv has to be the 1 dx. That's your only choice. So what's the derivative of this? What's the derivative of natural log? 1/x dx. What's the antiderivative of 1? 1, x, right? This is actually going to be really, really nice. This should equal ultraviolet, these two multiplied. I'm going to put it opposite order, x natural log x, minus the integral of voodoo, these two. Are there any constants that come out here? No, but what's x times 1/x? 1. So this is just 1 dx. Can you find the antiderivative of 1? X, right? So this is just x ln x minus x plus c. X ln x minus antiderivative of 1 is x plus c. There it is. That's the antiderivative of natural log of x. I am okay for you to write that on your formula sheets. It's not on your formula sheets, but very seldom do I allow you to add more to it, but this one you can add. Anywhere you want, you can put that. Antiderivative, this right here, equals that. I'll check it real quick. How would I check it? Product rule, right? Derivative of that's 1 times natural log x plus derivative of natural log of x is 1/x times the first one, x, minus the derivative of x is 1. This right here is 1. 1 minus 1 is 0. 1 times natural log of x is natural log x. So it's natural log x. It works. I know I do that fast, but. All right, test. I will not give you any integration by parts on your test on Monday. All right, I'm not going to give you any of these unless it's a bonus. I may provide you one bonus question where it's integration by parts. All right? Otherwise, let me pass this out. I told you last time this first test is an opportunity for you to do well. Quizzes are going to come around. These are the quizzes from last time. The grades should be updated, and then here are the reviews. Look, remember, do not look at this review as the only thing you need to study, right? I told you that last time. That I'm going to give you these. Don't ask me for answers. 4, 6. Here we go. I think I have enough. Let's see. There's extras coming? No? Should have enough. No. There you go. All right, everybody have a copy? So the There's two reviews, front and back. So the first one, think of these reviews as more of like concepts, right? Concepts you should be comfortable doing. So on the first review, number 1, you're being asked to find a derivative, right? That's it. And so those derivatives involve inverse trig functions, so you should be comfortable using the formulas and all that, chain rule, product rule, quotient rule. Number two on this one is tricky because I gave you homework problems like that, but I didn't do really anything in class like that. So make sure you look at number 2. It's an implicit differentiation problem. Number 3 is more derivatives using hyperbolic stuff. Number 4, I give you an acceleration function, and I ask you to go back and give me the position function. So that had to do with acceleration, velocity, position. And then number 5, we start with the integrals. So 5 is going to be something I did in class. 6, what are the only things I'm going to ask you in terms of integrals? Power rule or U sub, that's it, right? So all these can be done using power rule or U sub. If you look at the ones on the back, I think number 1 is that the same problem? No, pretty similar, right? Number 2 is similar. Number 3, I'm talking about the handwritten one. Number 3, show cosine hyperbolic x minus sine hyperbolic x equals e to the negative x. That was an identity. I did one in class where I did an identity. I proved one of the important identities for hyperbolics. It's here this is a test I gave. And then number 4 is integral, that's power rule. And then 5, I give you the second derivative, ask you to go back to the first derivative. So that's exactly like the acceleration, velocity, position problem. And then 6, 7, 8, 9 are all either U sub or power rule. I would not expect more than 10 questions on the test. I think 8 to 10 would be what you should expect. Study your homework. Study the review, right? Do you have any questions about anything? We still have 9 minutes, so. What we learned here is not on the exam, but you don't want to spend your entire next, rest of the week, weekend just studying for this. Like, we've already started stepping foot into this, so you should start trying to do some of the homework. I have not given you like the full treatment. We still have some more problems to do, but you can at least start the homework for 6.1. Also, I need to tell everyone that when you're doing your homework problems from here on out, until I tell you otherwise, when you're doing a problem, if you see any numbers on the top and the bottom of the integral, just ignore those. All right, just completely ignore them. All I want you to do is find the antiderivative. All right, that's it. Just find the antiderivative. All right, so yeah, what were you asked? What did you say? What did you say again?
I forgot what you
Oh, this material is not going to be on this test, other than possibly as a bonus, right? But that means it's on the next test, right? The next test is going to be it's usually one of the harder tests because it has all the different techniques are there, and so when you get the problems, you're not quite sure what to do. So here, at least you know it's only going to be what power rule U sub. That's it. And then the other material from before. So told you last time, this is a good opportunity for you to start off with a good test grade, but it's also not worth as much as the other test. So any other questions? I'm happy to go over anything on the review in the next 8 minutes, but otherwise 7 minutes. Otherwise, study. Are y'all going to do any study groups or anything? Or study? My most successful students in Cal 2 are the ones that get together outside of class and study together. So, yes?
I'm sorry, I don't understand where that negative x came from.
This right here?
Yeah.
Okay, what's the antiderivative of 1? So what do you take the derivative of to get 1, right? X, right? And then the minus.
Oh, okay.
Probably overthinking it.
I don't know.
Okay. I understand this can be pretty overwhelming, all right? So that's why you've got to get help. You cannot wait until exam 3. You've got to get help now to keep up with this. As soon as you get behind, it's really almost impossible to get caught up. So y'all come visit me in my office hours. Nobody's come for help. Maybe I'll start seeing people. Yes. What are you pointing at? Formula sheets? Yes, you may use all the formula sheets that are in our Canvas page under, I think it says formulas you can use on your exams. Anything in there you can use. But you can't bring like your favorite unit circle from pre-cal or something. It can only be the stuff that everyone else has, and you can't add stuff to it.
Unless you tattoo it on your arm.
You can tattoo it. You can have permanent tattoos of anything you want.
I genuinely think I might get a unit.
There's really cool unit circle tattoos. It's some of the coolest tattoos.
Until like a test.
Yeah, and then you just be like, yeah. Yeah, no, I'm okay if you want to get any formulas tattooed on your bodies. That's totally, I'm not going to tell you to not do it. Anything else?
What time are your office hours today?
Today, 12:40, no, 1 to 2. It's only 1 to 2. 1 to 2? Yeah, I have a class that goes to 12:40, then I go just eat real quick. So I'll be there from 1 to 2. And maybe even longer. I might be able to stay a little longer today. I don't know yet. I need to check. All right. Okay, we'll see you on Monday. Be on time. Be fed. Don't be tired. Don't stay up all night the night before. Sleep's important. Do what? I didn't, actually, but I handed back the quizzes, so you got your quiz out of there? Okay, so wherever they are, those are the people who aren't here.